Let's say we're in prehistoric times and we have two hunters sitting around a campfire one night and talking about the woolly mammoths they killed. And one hunter says he killed a woolly mammoth that was 10 stones big. The other hunter says, well, I killed one that was 200 stones big. And the guy that killed one that was only 10 stones says that's a bunch of bull because your stones are smaller than mine. And they get into a big argument because they're not able to communicate actually which one killed a bigger woolly mammoth. So and this is because they don't have a unit in which they have agreed upon. And so, before we dive into physics, we first need to define the fundamental units that we'll be using. Now, units are basically, they're sort of arbitrary, and some of these numbers I'll throw out here seem kind of very very arbitrary, but they're really just some standard for us to agree on so that we can communicate. If I say, this time period is 1 second, then we all know how long 1 second is. Or if I have a length of a meter, we all know how long 1 meter is. Not because a meter is something special, it's just that we all know what it is. So these fundamental units that we've all agreed upon. And there's three quantities that all physical characteristics can be described with these three quantities. And these fundamental quantities are mass, which we usually denote as m, the length, L, and time, T. Usually there's a lowercase t, uppercase t will mean a specific time that we'll cover later on. So these are the fundamental quantities. Every other physical quantity that we will talk about throughout the semester can be and will be expressed in terms of these three things: mass, length, and time. So previously, up until 1967, the unit of time, well, actually it was seconds even back then, but the fundamental unit of time is seconds. But up until 1967, it was defined in terms of the length of a day, which can get a little bit arbitrary. We try to get as scientific as we can with it, but days vary and where you are and etc. So since then, we've gone to a more exact definition of a second. So pictured over here is a picture of an atomic clock, and basically what an atomic clock is it has a cesium atom in it, and it changes between energy states, between its lowest levels of energy. That emits this radiation. And what we define to be 1 second is 9,192,631,770 cycles of this radiation. When that happens that many times, that's 1 second. So it happens 9 billion plus times, and we'd find that to be 1 second. So basically, we have this atom emitting radiation as it decays, and that is 1 second. So the fundamental units of time are seconds. And this is both in the metric system as well as the U.S. customary. So in both those units, or in both those systems of measurement, time is measured in seconds. And then next we move on to length. And the length used to be tied to the distance around the Earth, but again, after we got a more precise definition of time, we came up with a more precise definition of a meter. So I believe that was in 1983. I believe we came up with a more scientific definition of 1 meter. And a meter is how far light travels. So there's a picture here for a meter. It is the distance at which light travels in 1,299,792,458th of a second. So very, very short time interval, and how far light travels in a vacuum. It can't be in air and water or anything. Light travels differently in different mediums. So in a vacuum is the distance that light travels in that very small fraction of a second. So this is the units of length in the SI system, or the metric system, would be in, this is meters, which we use M for this as well. And in the US customary, it is in feet. So length is measured in feet. We'll predominantly use the metric system in this class, so usually we'll be talking about distance in meters. Lastly, we have mass. So a picture here is actually, this is a picture of a kilogram. So in the metric system, the standard unit of mass is a kilogram. We don't use a gram, we use a kilogram. And this standard is actually, so this is kg. This standard is very similar back to the story about the hunters and the stones. It's just this platinum iridium alloy that's kept in the International Bureau of Standards in France, and it's just this chunk of metal, and we said that is 1 kilogram. We just haven't gotten our measurement techniques and devices haven't gotten precise enough to measure mass on an atomic level, and that's why we still use kind of this more macroscopic scale for our units of mass in the metric system. So in the metric system, this is kilograms. And mass is really just how much material there is. There's a difference between mass and weight. So in the metric system, it is kilograms. And in the US customary, the units of mass are actually slugs. So this is this thing called a slug. It is not pounds. Pounds are actually a force, which we'll talk about later. It is not the same thing as mass. Now, oftentimes we interchange them, but really pounds and force depends on which planet you're on. Mass is actually just how much material there is. So we have and there's conversions between slugs and kilograms. This is still the standard. This platinum iridium alloy is still the standard kilogram, and then we can just convert it to slugs after that. So we have here, just make a little table. So we have mass, length, and time. And we have metric system and US customary. And mass in the metric system is measured in kilograms, and US customary is measured in slugs. Length in the metric system is measured in meters, and in the US customary it is measured in feet. And in both systems, the fundamental unit of time is seconds. So there we have our fundamental units. And of course we can use prefixes with these as well. So we have like C for centa means 10 to the negative 2. This is 1/100th. So a centimeter is 1/100th of a meter. We can also talk about centigrams, 1/100th of a gram. Talk about centiseconds, it'd be 1/100th of a second. So these prefixes can be put before any unit. Even we can talk about a centifoot as well. So C for centa And we have another one we use a lot is M for milli. This is 10 to the negative third, so 1/1000th. And K for kilo. This is 1,000. So a kilogram is 1,000 grams. A kilofoot is 1,000 feet. A mile is 5.28 kilo feet. We could discuss it that way as well. This M here is a lowercase m. We could also have a uppercase M, which is mega, and this is 10 to the sixth. And these are more or less all of the prefixes that we'll use in this class. But your book has a big table of prefixes that goes like from 10 to the negative 15th to 10 to the 15th.